Okay, so once again, good morning everyone. So this time our topic is the chapter 13, embedded operating systems. No? So in this topic, we cover the characteristics of embedded operating system, the ECOS, no? The tiny OS, and of course, the content of different topics that I was mentioned. Okay, so the intended learning outcomes of this topic covered. After this lesson, you should be able to explain the concept of embedded system, understand the characteristic of embedded operating system, describe the architecture of the key features of ECOS and TinyOS. So we examine one of the most important and widely used categories of operating systems, the embedded operating system. So the embedded system environment places unique and demanding requirements on the OS and calls for design strategies quite different than the found in an ordinary OS. No? So we begin with an overview of the concept of embedded system and then turn to an example of a principles of embedded operating system. And finally, this lesson surveys two different approaches to embedded operating system. Again, the term embedded systems refers to the use of electronics and software within a product as opposed to a general purpose computer such as laptop, desktop system. And of course, when we say embedded system, this will be a combination of computer hardware and software, and perhaps additional mechanical or other parts designed to perform a dedicated function. So in many cases, embedded systems are part of a larger system or product, as in the case of an anti-lock braking system in a car. Another example actually is the in our cell phone. No, we have a firmware there. No, as again, there is a hardware with a software, no? And embedded system far actually outnumber generally purpose computer system, encompassing a broad range of application, and this system have widely varying requirements and constraints. Okay, to give us more details about the topic, let us all welcome our presenter.
Good morning, sir. Good morning, classmate. My topic is embedded operating system. Embedded operating system. An embedded operating system is a specialized operating system designed to perform a specific task for a device that is not a computer. An embedded operating system is a specialized operating system designed to perform a specific task for a device that is not a computer. An embedded operating system main job is to run the code that allows the device to do its job. The embedded OS also makes the device hardware accessible to the software that is running on top of the OS. An embedded system is a computer that supports a machine. Example, include computers in cars, traffic lights, digital televisions, ATMs, airplanes, controls, point of sale, terminals, digital cameras, GPS navigation system, elevators, digital media receivers, and smart meters, among many others possibilities. Example of embedded operating system. Many modern electronic devices are based on Arduino or Raspberry Pi. Raspberry Pi device often run on ARM-based Linux kernel, but there are actually a number of different operating systems that can be run on Raspberry Pi device. Arduino device have a much more primitive embedded operating system that act as little more than a bootloader and a command interpreter. Example of embedded system and their markets. Ganyan. Possible organization of an embedded system. How, how an embedded operating system works. In contrast to an operating system for a general purpose computer, an embedded operating system can be quite limited in terms of function, depending on device. In question, the system may only run a single application. However, that single application is crucial to the device operation, so an embedded OS must be reliable and able to run with constraints on memory, size, and processing power. Our, an embedded operating system allows that device to do its job. In the case of Raspberry Pi, for example, an SD card acts as the device hard drive and contains the code that runs on device. Because the SD card is removable, its contents can be modified on demands. Because the embedded OS makes the device hardware accessible to the application that is running on top of the OS. Hardware components such as USB ports and HDMI ports can be leveraged by the application running on the device. Embedded versus non-embedded. An embedded operating system is integrated into a device and depending on device may reside on a chip. Embedded operating system tend to be limited in scope with regard to what they can do. And contrast, a non-embedded operating system tends to run from a hard disk or an SSD. Non-embedded operating systems such as Windows 10 or Mac OS tend to be user configurable and upgradable, and they are usually designed for general purpose use. Embedded operating systems, the basics. An embedded operating system is a small-scale computer of an embedded system with a limited number of features. It is designed to carry out a function or a set of functions of an electronic and products akin to this desktop PC that require an OS like Windows, Linux, or Mac OS to run basic apps. Embedded system also need an operating system to facilitate and expedite their functionality. For instance, our mobile phones have an integrated embedded operating system software like Android or iOS that starts up when the phone is switched on without the OS. Implementing an app into every single mobile phone with different hardware would have been a nightmare for the developers. It allows them bright all the gaps and build a unified app, especially for the OS. The embedded operating system is also known as a real-time operating system. In some cases, which we will discuss in another section. Here are some common characteristics of an embedded OS. power efficient, fewer storage capabilities, smaller processing power, fast and lightweight, I/O device flexibility, real-time operation tailored to the intended use case. The software incorporated into an embedded OS is critical to functionality of a product. At the at DG, almost all our products use an embedded OS to provide their features and performance. In the case of RDG, SAMS, ISOMS, a complete embedded OS used by developers adds huge benefits in unlocking sophisticated features of the SOM. Hardware and providing easy to use production ready code libraries and development tools to create future-proof and highly scalable products in the shortest possible time. That's all, and thank you for listening.
Okay, so as what our presenter mentioned, about the topic, a while ago he presented an example of embedded system in their markets. Let's say in automotive, we have ignition system, engine control, and brake system. For the consumer electronics, now we have cell phones, MP4 players, e-book readers, and so on. When it comes to industrial control, we have the robotics, and control system for manufacturing sensors. For the medical, at present we have infusion, dialysis machines, prosthetic devices, and cardiac monitors. But we are all familiar with the office automations like fax machine, photocopier, printers, monitor, and scanner. Now, another thing that we need to consider with this one is the characteristic of an embedded operating system. So, a simple embedded system with simple functionality may be controlled by a special purpose program or set of programs with no other software. So typical more complex embedded system include an OS. Now, although it is possible in principle to use a general purpose OS as Linux, for an embedded system, constraint of memory space, power consumptions, and real-time requirements typically dictate the use of a special purpose OS designed for the embedded system environment. So, the unique characteristics of operating system, as of course requirements for embedding operating system, is the real-time operations, reactive operations, configurability, input-output device flexibility, streamlined protection mechanism, direct use of interrupt. So there are two general approaches to developing an embedded OS. The first approach is to take an existing OS and adapt it for the embedded application. And the other approach is to design and implement operating system intended solely for embedded use. Now, so another thing, as I mentioned earlier, is the ECOS. ECOS is the Embedded Configurable Operating System. Okay, ECOS stands for Embedded Configurable Operating System. This will be an open source, actually, royalty-free, real-time OS intended for embedded application. So the system is targeted at the Linux, of Linux or other commercial OS, would not provide the streamlined software required. So the ECOS, or the Embedded Configurable Operating System, has been implemented on a wide variety of processor platforms, including Intel IA32, PowerPC, SPARC, or ARM, RISC, MIPS, and Muse V810, 20, RxS. It is one of the most widely used embedded operating system because it is implemented in C language and the C++. Okay, so the other one, of course, is the a while ago I've mentioned about the Tiny OS, no? The Tiny OS, of course, a while ago, no, I reiterated that the ecosystems provides a more streamlined approach for an embedded OS than one based of a commercial general purpose OS, such as embedded version of Linux. Thus, ECOS kasi is a similar system are better suited for a small embedded system with tight requirements on memory, processing time, real-time response, power consumption, and so on. Now, on the other hand, the Tiny OS takes the process of streamlining to a much further point, resulting in a very minimal OS for embedded system. The core OS requires 400 bytes of code and data memory combined. Again, the Tiny OS represents a significant departure from other embedded operating system. One striking difference in the Tiny OS is not a real-time OS. Again, Tiny OS is not a real-time OS. The reason for this is that expected workload, which is in the context of wireless sensor network, as described in the next subsection. Now, because of power consumption, these devices are off most of the time. Application tend to be simple with processor contention, not much of an issue. Again, in Tiny OS, there is no kernel, as there is no memory protection, and it is component-based OS. There are no processes. The OS itself does not have a memory allocation system. But although, of course, some rarely use components to introduce one, no? Interrupt and exception handling is dependent on the peripheral, and it is completely non-blocking. So there are few explicit synchronization primitives. Tiny OS has become a popular approach, no, to implement wireless sensor network software. Now, currently, over 500 organizations are developing and contributing to an source standard for Tiny OS. Again, an embedded system is a specialized operating system designed to perform a specific task for a device that is not computer, as what our presenter mentioned earlier. Okay, so an example of an embedded system, of course, include Windows Mobile, no, the handheld personal data assistant, the Symbian cell phones, and Linux. No, flash memory chip is added on a motherboard in case of embedded operating system of your personal computers. No, of course, we find embedded system everywhere around us in our daily life. Embedded systems are especially designed computer system that essentially contains software and hardware for performing specific tasks. Yeah, mobile phones. Sa mobile phones, we had firmware. No? We have laptops, no, cameras, washing machines, ATM, hair straighteners, no, and others. You can, of course, also check the medical applications of embedded system. No? So, as the name suggests, embedded operating system is an embedded system operating system. It has limited features. It is usually designed for a particular operations to control an electronic device. For instance, all mobile phones essentially consist of an operating system that always boots up when the mobile phone is in running condition. It controls all the features and basic interface of mobile phone. And there are some other programs that can be loaded onto the mobile phone, mostly like Java apps, run on the top, embedded operating system runs on the embedded processor. Real-time operation, streamlined protection mechanism, and input-output, of course. No? Down. Okay, so the real-time operating system, no, is the one which serve real-time applications. So it processes data as it comes in. No? The time requirements for processing of operating system are usually measured in shorter increments in the 10th of seconds. And then they may be time sharing or driven by events. Now, real-time operating systems are used in a small embedded system. So the main features, of course, include the process threads that can be defined, multitasking, and interrupt levels. So When it comes to applications, no, as I mentioned earlier, no, Symbian, no, it is used in mobile phones mainly in Nokia. No, BlackBerry operating system, it is particularly used in BlackBerry phones, of course. Embedded Linux, it is used in Android phones and other devices like printers. iOS, it is used to Mac operating system and other Apple devices. The Windows Mobile OS is used in Windows Phone also. Okay, so I think that's it for this topic.